Okay, hello everyone. Thanks for coming to this presentation on GitHub Actions and how to make it faster and 10x cheaper. But first, a brief primer on GitHub Action. And especially the good parts. So GitHub Action is a way to run workflows automatically whenever you push code, open a pull request, or do anything on your repository. It has very high adoption, a flexible workflow syntax, and a large choice of architectures. So you can run workflows targeted at Linux, x64, Mac OS, Windows. So it's quite versatile and really useful. But yeah, the bad parts. Let's see. The first thing is like the CPU performance of the runners is not great. If we have a look at this example, this is the Node.js build workflow, and below we can see like the GitHub performance using the default runner with 2 CPUs and the larger runner with 16 CPUs. So default runner 1 hour and a half, 16 CPUs half an hour, so better but quite expensive. And if we compare to other third parties like Buildjet, Warbuild, UbiCloud, it's below half an hour. And if we compare with RunsOn, it's like 22 minutes, so much faster. And also, as you can see here, much cheaper. And yeah, so GitHub is quite expensive, and this is due to like the 2-core machine is priced like $0.008 dollars a month, which dollars per minute, sorry, which amounts to more than $300 a month if you were to use it fully. And if we compare that, like if you had to bring your own machine at a provider like Hetzner for a bit more than €100, you could have a 60-core CPU machine, very recent CPU as well, so at least almost twice faster than the Azure CPU, as we'll see in a moment. So yeah, not great in terms of pricing. And then the cache speed as well is not that great. Like it seems there is a 100 megabit second limit. And so this means like if we take, for instance, a 5 gigabyte file, it will take almost 3 minutes to upload to the cache and 2 minutes to restore. While, as we'll see in a moment, my software RunsOn is able to do that in about 30 seconds. And there is still no native RM64 runner available, although they have something in beta preview. This means like if we were to compile for multiple architectures, yeah, on the normal x64 it's fast, but on RM64 it's emulated and it's really slow and painful. And finally, the fact that GitHub only provides underpowered machines, like with 2 CPUs, not so good CPU. And this means like a lot of people at lots of companies have spent a lot of time splitting their test suites just to get under like 10 minutes or 20 minutes runtime. And yeah, you couldn't believe the engineering time wasted on this, and I'm probably sure you have already seen this in your own companies. And this is just due to the fact that we don't have access to better runners. So the solutions, I guess the easiest solution is just to bring your own machines. And this is possible because GitHub allows the use of self-hosted runners. So you basically just bring a server online, you install some commands, you configure the runner agent with a dedicated token, and then that agent will start executing jobs. And so assuming that you selected a good machine and you have reasonable bandwidth at your provider, then you should get faster builds for much cheaper. But there are like multiple levels of self-hosted runner setups. So the first one we've just seen, it's what I call Artisanal. You just bring your own machines, a few of them, you register them with GitHub, and here we go. So it's definitely cheaper. It can be manageable if you have like less than 5 or 10 machines maybe, but then you hit some limits. Like you cannot have a lot of concurrent jobs running at the same time because you are limited by the number of servers that you have. You have to maintain, patch them, and there is no clean state between jobs. So this means every job is executing on the same VM, and if you are not really careful, it could leave some stuff behind. Could be secrets, could be some code. So it's a big security exposure for public repositories, and even for private repositories, it's not good. And also as well, there is no image compatibility with official runners. So there is no way to exactly replicate the environment that you have on GitHub. So the second level here is what I call the productized on-premise. So it's basically same concept, self-hosted runners, but with a lot more software around. So this is things like the Action Runner controller or the Philips Terraform project. And here you can still benefit from cheaper machines, obviously, better concurrency, because most often the orchestrator can launch VMs on demand or auto-scale the cluster to ensure you have enough runners for your workflows. It's quite flexible in terms of hardware with a bit of configuration, but yeah, the downsides, it requires a lot of expertise, maintenance costs always. There is still no image compatibility with official runners, so you have to basically bring your own Docker images as a base or build your own AMIs on AWS. And yeah, if using Docker, it leaves open a lot of security issues, because if you want to do some Docker in Docker, then you have to open up some privileges on the cluster. And the last level is like just rely on a third party to provide cheaper machines. There is a lot of contenders in this space, as we'll see in a moment. The advantage, obviously, is it's no maintenance on your side, just pay, and you get what you pay for. They all support official images, or almost all of them. And yeah, small downside, they're only 50% cheaper for most of them. And yeah, you have to relinquish your repository content and secret securities with them, because they are running the machines that execute your workflows. So if they have a breach, your secrets could be at risk. They are not so flexible in terms of hardware. Like you can only select basically the number of CPUs, but not the processor, not the disk space, not GPU. If you want elevated concurrency, like it can be pricey. Some providers, if you ask for more than 64 CPUs in total concurrently, then you have to pay to get more, which is quite a low bar. And they are often hosted at places where the network speed is not that great. So let's have a look at the markets. So I've put here three columns. Like on the right, you have the third parties, software as a service. So you have quite a lot of choice here, with a new one every month or so almost. On the left, you have the fully on-premise stuff, so the Action Runner controller, the Terraform provider, and a newcomer, which is AWS Code Build, which allows you to manage runners within your AWS infrastructure. And at the center, there is a mix of, there are providers with a mix of both on-premise and SaaS. So basically you bring the machines, so you host them in your infrastructure, but you still have to go through their own control plane for it to work. And so here, like when I was looking for a better solution for self-hosted and especially cheaper one, I was a bit surprised to not find something better. Those solutions on the left are pretty hard to set up, and they're not that fast to boot. The queuing time is not great. AWS Code Build is expensive. It has limitations. So yeah, I was thinking maybe I can build something better. And so what would it take to build a cheaper, faster, productized GitHub Action Runner fully on-premise? And yeah, my answer is RunsOn. Obviously, that's the software I am currently developing. As a disclaimer, RunsOn is free for individuals and non-commercial projects, but it comes with a paid license for commercial projects. So either a standard license or a sponsorship license where you can get access to the full source code. So, but I guess like when I started, I thought, okay, it cannot be hard, right? I mean, GitHub, it will publish anytime a workflow is queued, you will get an event. So you can just receive that event and act on it. So basically receive the event, spawn a VM on, for instance, EC2, and whenever the job has finished, then kill the instance and you're good. And this can actually work pretty well. Like if you don't have a lot of jobs and are okay with debugging some transient issues sometimes. But our ideal checklist was a bit more complex. So what I wanted as core features, obviously, first one I wanted faster and cheaper runners. I wanted them to be scalable, so I don't want to be limited in terms of the number of jobs I can run concurrently. I wanted to have full image compatibility with official runners, so I can just change one line in my workflow and they would be compatible with RunsOn. And finally, I wanted to be low maintenance. Like I don't want to spend engineering time running it or babysitting it. So it has to work. And some nice to have features would be being able to select the instance type quite flexibly. So in terms of CPU, RAM, disk, GPU, etc. I wanted to have at least x64 and AMD 64 and possibly macOS. Possibly do something about caches and Docker layers, and wanted something to be as easily installable and upgradable as possible. So if we take the first core feature, like make it faster, I guess in that case, it's quite easy, right? You just pick a provider with access to better CPUs, so Hetzner, AWS, OVH, whatever you want. And it's really not difficult because the GitHub machines at this time, they are quite very slow, as you can see on the graph. So I maintain a benchmark of all the GitHub Action providers and their CPU performance. So here RunsOn around 3000 in the CPU pass mark benchmark. And you can see BuildJet has runners that are faster, some slower, but GitHub is definitely the slowest. And you can see all the other providers on the benchmark page. So yeah, for RunsOn, I went with AWS EC2 because of the large instance choice, many family types, many architectures, even GPUs. And also because they have spot pricing. And that leads to the second core feature, make it cheaper. So if you're going for Artisanal on-premise, I mean, just use Hetzner. The AX102 server line is really great for the price. But in my case, if you want something more productized, then yeah, AWS EC2 with spot pricing is definitely a good choice because spot instances can be up to 75% cheaper than the on-demand price. And it fits well with CI workloads because a large majority of CI jobs can be short-lived. It's not often that you find jobs that live for more than 30 minutes or even 1 hour. And you have a really low probability of interruption if you are below 1 hour time. But it can still happen, spot interruptions. So I had to find a solution for this. And the solution I found is basically you just use a create fleet API provided by EC2, because with this API, you can basically just tell, okay, I want this kind of instance, number of CPU, number of RAM, family type, and then I don't care on which availability zone you take it from, but I want the one with the least likelihood of interruption. And AWS will just internally do its job and select the pool of machines that contain a machine with the least likelihood of interruption. So very, very handy. So I guess, yeah, that part as well, easy enough. And the result is like 5 times to 15 times cheaper compared to GitHub. So you can see the details here. And obviously it depends on the region where you are located, whether you do a mix of spot and on-demand, which kind of instance family types you use, etc. But the savings are really, really meaningful. So the third core feature I wanted is for RunsOn to be scalable. Like with Artisanal on-premise, you are limited by the number of servers you have. With productized on-premise, it can launch a lot of concurrent jobs, but it's not optimized. You have long queuing times, and it could be better. So in the case of RunsOn, what we do is simply like keep it simple. So whenever a job comes in, we launch an ephemeral EC2 instance, and we terminate it when the job ends. The only limits really for concurrency are your AWS EC2 quotas. And to ensure that we have fast queuing times, we optimize really hard the base AMIs, use provision network throughput to pull EBS blocks fast. And this results in really good queuing times, around 30 seconds currently. GitHub does 12 seconds. and it's so the 30 seconds is much better than Action Runner Controller and many other third-party providers. So on the benchmark, you can also see the queuing times, average P95. And as you can see, RunsOn is really like in line with other providers, a bit slower maybe, but it's not really meaningful. And to finish on the scalability, I did a lot of work with one of my clients, Alan, to make sure that the queue time stays stable, even if you have a large number of jobs incoming, like if you have bursts of 100 or even more. As you can see on this graph, you have bursts of jobs, but the queuing time stays exactly the same, which is great. Core feature number 5, 1.1 compatibility with official runners. So basically, I wanted to do just this, change one line, and my workflow should still work. This is probably one of the hardest parts because you have to make compatible AWS images, in my case, for EC2, and nobody did this, or nobody published it at least. So in my case, thankfully, GitHub publishes the Packer templates for their runner images on Azure. So I just ported them for AWS, and this is now available for anyone to use. You can find the repo links here. And final feature, low maintenance. And so, as you can see, the architecture diagram has changed a bit since the last slide. But basically what I use for RunsOn is just managed services everywhere and cheap services. So I have basically one CloudFormation stack which provisions an SQS queue, an SNS alert topic, a CloudWatch, logs and metrics, and some S3 buckets. And then the app runner service is just running on, the RunsOn server is running on the app runner AWS service, which is really a cheap way to run containers on AWS. I recommend you check that out. And yeah, on the VMs, there is a small RunsOn agent that launches to configure the VM and then register with GitHub. And all that stack, like if you have reasonable number of jobs, it costs only about $1 or $2 a month, which is pretty impressive. So that was it for the core features. So basically, I was able to make them all work, which is great. And I also have some nice to have features I wanted. So flexible instance selection. I'm quite proud of this one because just by using dynamic labels on the RunsOn element in your workflows, you can specify whether you want 4 CPUs or specific amount of RAM or specific amount of disk. You can choose one or multiple families, and you can also bring your own images, which is a really nice feature. More on that in a moment. I was able to do it for both RM64 and AMD64. Unfortunately, macOS on AWS, but it's just due to licensing issues with Apple. You are required to book a host for 24 hours, even if you use it for like 10 minutes. So obviously not great for an on-premise solution with on-demand runners. So yeah, for now, no macOS, but maybe at some point in time, if Apple changes their licensing terms. And I also wanted easy one-click install, one-click upgrades, and yeah, you can do easier than that. You just copy-paste the template URL, click next, and you're done. A really, really nice feature that I was able to implement is a drop-in replacement for the official cache action. Because since we are on AWS, we have access to an infinite cache backend, right? It's S3. And since you are since the S3 bucket is co-located with your AWS VPC, then you get insane speed between your runner VMs and the S3 backend. So that means by switching only one line, you can get up to 5 times faster caches, as I showed in the first slide. And more than that, you can actually use that S3 backend to cache Docker layers. So just by adding those 2 lines, cache from, cache to, we are able to reuse the same S3 bucket with infinite space and cache Docker layers there. And you could ask, okay, but I have to set up some credentials, address credentials, whatever in my workflows, but actually not, because we attach, there is a EC2 instance profile attached to your runners with the permissions to access that cache bucket. And so your runners all transparently get authenticated to that S3 bucket. So really great, sorry. Check out the links I put in reference. And last, nice to have features. So bring your own images here. So really handy, like if you want to preload software, put Docker images on a custom AMI, you can just declare your custom images here and reference them in your RunsOn workflows. So really handy. Full SSH access. So you have full SSH access to your runners when they are running. And you can restrict that with CID or Range if you want to. And you can also enable full private networking and have static egress IPs for all your runners, which is really handy if your runners need to talk to APIs that are behind firewalls, like to deploy production code, for instance. So yeah, quite a really complete stack in the end for RunsOn, and some real-world results. So here you can see on the left, like two of my sponsors. First one, Spinergy, was able to reduce by 85% their costs while increasing speed. Alan is currently doing a migration, launching more than 20,000 jobs per day. And all in all, across all clients, currently RunsOn is launching more than 500,000 jobs. And yeah, catering for clients like who have only 10 to 100 jobs a day up to 20,000 or even more jobs a day. So it's really versatile in the terms of who can use RunsOn and who will benefit from it. And on the right, we can see, like, if we take the slide that I was showing in the bad parts of GitHub Action with the slow RM64 compilations, well, I mean, we can see the effect of having native RM64. Timings are just infinitely faster. And even for AMD 64, faster runners and taking advantage of the faster cache as well results in a much better timings. So future work for RunsOn, like right now, it's quite feature complete, but I'd like to add some nice touch, and especially around like making sure that developers are aware of the CI costs, because most often, okay, it's really fun launching lots of jobs, but it's quite costly, as I showed on the first picture, and also like the environmental cost is probably huge. Some companies, whenever you push one line, it triggers hundreds of VMs. So this cannot this cannot come at no cost. So I'd really like to surface this information, and I'd like also to add something about monitoring, and especially providing some reports whether your runners are correctly sized or not. So it could be that you are wasting money on 4 CPUs while you need only 2, or contrary, you are really reaching the limit of your runner. Obviously, macOS support would be nice because there is quite a strong demand for it. And maybe expand to some other integrations like with GitLab or some other cloud providers instead of EC2. That part I'm not sure. Yeah, so in the end, I managed to put RunsOn on the map. I think a lot of customers now, and yeah, a lot of interests from competitors. So I really think this is the best fully on-premise solution right now. So I encourage you to really check it out. So it's runson.com, and there is the part of the project that is still open source at github.com/runson/runson. Thanks a lot, and yeah, let me know in the comments if you need any tips for your workflows, and you can reach out to me at my private website here. Bye bye.